Hello everyone. Today I'm going to present my homework project, which is about controlling an RC servo motor by using an potentiometer and Arduino. This project is servo motor angle can be adjusted by rotating the potentiometer and the related volumes are displayed on LCD screen. This project helps us understand both hardware connection and Arduino programming. This project uses an Arduino board to control an RC servo motor. An potentiometer is used as the input device. Then the user turns the potentiometer. Arduino reads the analog volume and converts it into a corresponds servo angle. At the same time, an I2C LCD is used to display the potentiometer volume and the servo angle in real time. So this is simple to complete input-output control system. The main objectives of this project are listed to this page. First, it helps us learn how to read analog input from a potentiometer. Second, it shows how to control the rotation angle of an RC servo motor. Third, it helps us understand how to map an input signal to an output signal. In addition, we can learn how to display useful system information on an LCD screen and improve our practical Arduino programming skills. These are my components used in this project. They include an Arduino board, an RC servo motor, an potentiometer, an I2C LCD display, and breadboards, firmware, and a USB power supply or computer. Each component has its own function. Arduino board is the controller. The potentiometer provides the input signals. The servo motors is the actuators, and the LCD is used to display information. This page shows the working principle of the system. First, the user rotates the potentiometer. Then Arduino reads the analog volume from pin A0. After that, the input volume is filtered and processed to make the signal more stable. Next, the volume is mapped into servo angle from 0 to 180 degrees. Finally, the servo motor rotates to the target angle, and the LCD display both the potentiometer volume and the servo angle. This page shows the current accuracy. This page shows the skill combination of the projects. The potentiometer out pins is connected to Arduino analog pin A0. The servo motor signal pins is connected to digital pin D9. The LCD is connected to connector through the I2C interface. All components serve the six power supply and the grow connection. Serial wiring is very important because it ensures that the system can work properly and stably. This page explains the program design. In projects, the servo library is used to control the servo motor, and the liquid crystal I2C library used to control LCD. The Arduino read the potentiometer volume 0 times and use average filtering to reduce noise. Then the program uses the map function to cover the potentiometer volume into a servo angle. The constraint function is used to keep the angle within the valid range from 0 to 180 degrees. Finally, the LCD continuously alters the potentiometer volume and the servo angle. This page shows the keys idea of the code. The function deploying filter read the potentiometer volume with a regime, so it can reduce the signal noise. Then the map function calls the input range into the servo angle range. After that, constraint prevents the angle from going beyond the value limit. Finally, my servo write send the command to servo motor and makes the data to the required function. This function work together to make the system acute and stable. This page process the independent result of the project. This servo motor data small according to the possible position of the potentiometer. The LCD can carry the display both potentiometer volume and the servo angle because average filtering is used. the input signal become more stable and the servo movement is smaller. Overall, the system responds in real time and works as expected. In use, this project also use a potent motor and control a servo motor with Arduino. It shows that Arduino can cover analog input and process motor motion control. The LCD display allow also makes the system more user friendly and easier monitoring. Through the projects, I improved my understanding of Arduino programming, signal processing, and hardware control. Thank you for listening. Listen to my presentation. See you next time.